Okay, so in this video, we're going to talk about solving exponential and logarithm equations. If I look at letter A here, I've got 7 to the x power is equal to 12. Now, I don't know anything 7 to some power to give me 12, so there's a function we can use to undo an exponential, and that is a log. So I can take the log of both sides, and then using our power rule, we can rewrite that as x times log 7 is equal to log of 12. Then if I'm solving for x, I can divide by the log of 7 on both sides. That's just a number. So x is equal to log of 12 divided by log of 7. This is our exact answer. So if the question asks for an exact answer, that means we are not rounding. But if it wants it as an approximated answer, we can plug this in the calculator and we get about 1.277. Okay, now up at the beginning here, I could have chose to do the natural log of both sides. And I would solve this the same way, and we would still end up with the same answer of x being 1.277. Okay? All right, let's go ahead and look at letter A here on example 2. So again, I have exponentials and I need to rewrite this so that I can get those exponents out. So I'm going to take the natural log of both sides. I could have taken the log of both sides and that would be the same thing. And now let's rewrite this by taking those exponents and moving them down in front of our numbers to give us 3x plus 1. That's the whole quantity times the natural log of 2. And we have 4 minus x times the natural log of 3. Okay, well, we're trying to solve for x. So it's a bit of an issue that we have x's on both sides and they're in parentheses. So that means we're probably going to have to distribute that natural log of 2. So let's go ahead and distribute that. That's just a number. So when I distribute the natural log of 2, we have 3x times the natural log of 2 plus the natural log of 2 is equal to 4 times the natural log of 3 minus x times the natural log of 3. Now, still a bit of an issue because I've got x's on the left and I've got x's on the right. So let's move our x's onto the same side here and isolate our x variable. So I'm going to add x natural log of 3 to both sides. That's going to go away. And I've got 3x natural log of 2 plus x natural log of 3. And why don't we go ahead and move this natural log of 2 to the other side. So this now equals 4 times the natural log of 3 minus the natural log of 2. Okay, we're getting somewhere. We should see now that I've got an x here and an x in the second term. So I can factor out an x to give me x times 3 natural log of 2 plus the natural log of 3. And then that same thing on the right side. And now that x is by itself here, I just need to divide by this 3 natural log of 2 plus the natural log of 3. That's just a number, so we're just dividing by this number. So this right here is our exact answer. We have not plugged in anything into the calculator yet. But if you do plug this in the calculator, you should get approximately 1.165. So double check that you can plug this in the calculator. Remember, if you're trying to write a fraction, use the button alpha y equals to help you type all this stuff in so you make less mistakes. All right, let's look at letter B here. Letter B, I've got log base 3 of x plus 6 minus log base 3 of x plus 2 is equal to a log base 3 of x. Okay. Well, I need to rewrite this as one log so that way I can go ahead and do some simplifying here. So when I'm subtracting, that's the same thing as dividing. So I've got log base 3 of x plus 6 divided by x plus 2. And that equals log base 3 of x. Now this time I've got logs on both sides. So to undo a log, technically we need to raise it to the power of that same base. So if I took 3 and rose this whole thing to that power, those logs and the 3's are going to cancel out. So now I'm just left with x plus 6 over x plus 2 is equal to x. So we can cross multiply. This is over 1. So I get x plus 6 is equal to x times the quantity of x plus 2. Now I can distribute here, and we should see that we're getting a quadratic term on the right side, which means we're probably going to have to factor here, so we need to get everything equal to 0, so I'm going to subtract x and subtract 6 to get 0 equals x squared plus x minus 6. Okay, if we factor this here, we're thinking what multiplies together to give us -6, but adds to give me 1. And those numbers are positive 3 and -2. So our answer, I can set each of these equal to 0. So I get x equals -3 and x equals positive 2. However, we need to remember our domain. If I go back up to this original problem that we were given, last class we talked about everything in this argument here for all of these. All of those things have to be greater than 0. So if I set up an inequality for each of these, this tells me what x has to be greater than. So if I solve all of them, I get x is greater than -6, x has to be greater than -2, and x has to be greater than 0. So if we look at all 3 of these, they all have to work when I'm plugging in these values for x. So if we think about a number line here, I've got -6, -2, and 0. Well, this one tells me that I'm just everything to the right. This one tells me at -2, I'm everything to the right. And this last one tells me anything bigger than 0. So our winning domain is actually x greater than 0. So if I go back to my answers that I was given, or the ones that I solved, I got x equals -3 and x equals 2. So -3 is not in our domain, but x equals 2 is. So make sure you check your domain when you have logarithmic functions. Okay. All right, let's look at another one. Example C. Okay, I see that I've got a log, so I'm going to go ahead and start by solving for my domain. I know that these arguments here both have to be greater than 0. So 3x plus 2 is greater than 0, and x minus 1 has to be greater than 0. So if I solve this, I get x is greater than -2/3, and x is greater than 1. So all of my x values that I plug in have to work in both of those domains. So it looks like our winning domain here is going to be x is greater than 1. Okay? So now that I've got 2 logs here, I need to rewrite this in terms of 1. So when we're adding, that really means we are multiplying these 2 bases together. Or not the bases, but our arguments there. And then if I'm trying to solve this here, I know that this log, when there's no base there, it's automatically a log base 10. I can rewrite this in terms of an exponential by taking 10 to the first power is equal to that whole quantity of 3x plus 2 and x minus 1. Okie dokes. So now I'm going to go ahead and distribute. And since I've got a quadratic, that means we're probably going to have to factor to solve. So I'm going to move this 10 over. Okay. So I can go ahead and think what multiplies together to give me 36, negative 36, and adds to give me negative 1. I'm not sure about that one. So let's go ahead and use, instead of doing the quadratic formula, go ahead and use the polysmelt function on your calculator to get some more practice with that. Or you could use the quadratic formula. Either one will get you the answer. And the two answers that you should have gotten, whether you used polysmelt function or you did the quadratic formula, we should have gotten negative 1.84 and 2.17 approximately. So let's look back up here at my domain. Remember, my domain has to be greater than 1 that we found. So I am going to omit that answer of negative 1.84, and we are going to accept the answer of 2.7 for this problem. All right, looking at letter D here. So I've got a logarithm function, so I need to look at my domain here. So this 2x has to be greater than 0. So that means x is greater than 0. Now before I can rewrite this in terms of an exponential, we do need to get the log by itself. So I need to divide by 3 on both sides. And we get log base 2 of 2x is equal to 5. Now we can go ahead and rewrite this as 2 to the 5th power is equal to 2x. And we can divide by 2 on both sides. And that gives me x to the 2, 5 minus 1 would be 4, or that is 16. So x equals 16. Okay, letter E here, I have a base of E. It's written as an exponential already, so I need to get rid of the stuff in that exponent. So we're going to take the natural log of both sides because natural log of E is actually 1. So that's going to go away here in a second. And then I've got E to the power of 1 over 16. So natural log of E is equal to 1. So we're left with negative 2 times the natural log of x equals E to the 1/16th power. And I need to divide by negative 2. So now we have the natural log of x equals E to the 1/16th all divided by negative 2. And in order to get the natural log to go away, we can think about rewriting this as log base E of x. So I could rewrite it as an exponential. So that would be E to the E 1 over 16 divided by negative 2 power is equal to x. Or we also know that if I take and raise this whole thing of the natural log of x of both sides, if I take it and put it as a base of E to the power of, those also simplify out and give me 1. And then I would have E to the power of everything here, just like we ended up with. So this is my exact answer. But if we approximated it, we should get about 2.636. All right, if I look at letter F here, we are solving a logarithmic function here. So I do need to look at my domain. I've got this x minus 3 here as my argument. So x minus 3 has to be greater than 0, or x is greater than 3. And now we can go ahead and start solving. Right away I see this natural log of e. We should instantly be thinking we can simplify that out to be 1. Okay, those are inverses of each other. So now I have just the natural log of x minus the natural log of x minus 3. So I know my property of a log says that if I'm subtracting with the same base, I can go ahead and divide. So I've got log of x divided by x minus 3 is equal to the natural log of 2. And now if we think of taking and putting an e to the power of on both sides, these have the same base, so those simplify out to give us 1. And we're left with x divided by x minus 3, which equals 2. So now we just gotta solve this equation. I get x equals 2 times the quantity of x minus 3. So I get 2x minus 6. So I get x equals positive 6 for my final answer, and that is in fact greater than 3, so we are good to keep that answer. Alright, letter G here. If I start moving things around or trying to factor stuff out, the only way that I can get e to the 2x is if I have e to the x times e to the x. So even if I moved this 3 over to the other side and I factored out an e to the x, I still wouldn't be able to isolate the x variable from everything else. So we gotta do something else. Okay. What if instead this said x squared minus 4x plus 3 equals 0? If you saw this, what would you do? Pause this video and factor this problem. Okay, hopefully you paused that video and hopefully you solved. And when you factor, you get x minus 3x minus 1. So your answer is x equals 3 and x equals 1. Okay, we're going to use this idea, except for instead of my x, we have an e to the x. Do you see how I can just kind of replace both of those? So we are factoring this problem here. Instead of having an x, though, as our first term, we're going to have e to the x, or sorry, to the x as our first term, because when I multiply these two things together, e to the x times e to the x is e to the 2x, right? Just like if you have a base that's the same and we're multiplying another base with a different exponent, this becomes the same base but raised to the 4 plus 3 or 7th power in this case. Okay, and then we ask ourselves the same questions. So what multiplies together to give us 3 and adds to give us negative 4? Well, we already answered that. It's minus 3 and minus 1. Okay, this whole thing equals 0. So does this mean my answer is just 3 and 1? Well, not quite, because I have e to the x minus 3 is equal to 0, and I have e to the x minus 1 is equal to 0. These are still some exponentials that I need to solve. So over here on the left, I've got e to the x equals 3, and if I want to get x in the denominator, or sorry, if I want to get x down from the exponent, I need to take the natural log of both sides. So that goes away. I'm left with x is equal to the natural log of 3. Similarly with my 1, I've got e to the x equals 1. I have to take the natural log of both sides. That goes away and gives me 1. So I have x equals the natural log of 1. And both of these here are answers. I don't have any domain restrictions there. So we are good. And then the last question here, all it is just a literal equation. You guys saw these before in Algebra 1 and Algebra 2. If I just want to solve for a variable here, we're gonna treat it the exact same way as we are all of these other equations here. So I'm gonna start solving this equation for k, but we're gonna have to get it out of that exponent there. So first I'm gonna go ahead and distribute this 1,000 to both terms. Okay, now I'm gonna move this 1,000 to the left side. And we have to have our exponential by itself before I can actually take the log of both sides. So we're going to divide by negative 1,000. And now I have this h minus 1,000 divided by negative 100 is equal to e to the negative kn power. Well, if I want that stuff in the exponents to get down, I need to take the natural log of both sides. This now becomes 1, and I'm left with the natural log of h minus 1,000 divided by negative 100 is equal to negative k times n. And then if I'm solving for k, I need to move everything else over to the other side, so I'm going to divide by negative n and divide by negative n. So k is equal to this natural log of h minus 1,000 all divided by negative 100, which is then all divided by negative n. Okay, so that's kind of a tricky one, but it's just testing to see if you know how to solve these exponential and logarithmic equations without these numbers as well. Do you know your rules? Okay, so try out the homework. If you have questions, please let me know. Thanks for watching this video. And if you truly watched and listened to this video, thank you very much. It will help you in the end. But go ahead, just because I am so kind, shoot me an email and tell me something fun you're doing this weekend or something fun that you did this weekend. And I will give you an extra 2% extra credit on your previous quiz. Have a great day, and I will see you guys next class.